Good morning to everyone. I'm Dr. Sumi MS. The topic of my today's presentation is Precipitation Methods, Sol Gel Technique from Unit 2 Synthesis of Nanomaterials, Nanotechnology. On completion, the students will be able to explore about precipitation methods in nanotechnology and also understand the step-by-step procedure of sol gel process. Precipitation methods. Precipitation method is a bottom-up synthesis approach that involves the formation of a solid phase precipitate from a solution due to chemical reactions, and they are commonly used to synthesis nanoparticles of metal oxides, hydroxides and salts. General steps involved in the precipitation method are: they dissolve the metal precursors which are in the form of nitrates and sulfates in a solvent which is usually a water. Add a precipitating agent such as NaOH or NH4OH and control parameters like pH, temperature, concentration and stirring. And aging and washing of the precipitate is the next step. Finally, we subject it to drying and calcination to get the final nanoparticle powder. Applications. These are used for synthesis of zinc oxide, titanium dioxide, Fe2O3 as well as CaCO3, and they are applied in pigments, catalyst as well as drug delivery system applications. Sol gel technique, a specific technique of precipitation method particularly used for fabricating metal oxides as the nanoscale range, is a sol gel technique. The sol gel process involves the transition of a system from a liquid in the form of sol, that is colloidal suspension, into a solid gel which is in a 3D polymeric network form. Sol gel process step-by-step procedure. Step 1 is the hydrolysis, where metal alkoxide or metal salt is dissolved in a solvent. Water is added to hydrolyze the metal precursor. Step 2 is condensation. Hydrolyzed products undergo condensation reactions forming metal-oxygen-metal bonds. Step 3 is the gelation. This is the formation of a network structure, that is the gel is being formed which occurs as polymeric chains interconnect. Step 4 is aging. Here the gel structure strengthens and shrinks as byproducts diffuse out. Step 5 is the drying process, that is the removal of solvent leading to serogel or aerogel depending on the drying method used. Step 6 is the calcination. Here thermal treatment is applied to remove organic residues as well as and crystallize nanoparticles. Advantages of the sol gel technique. Here low temperature processing is only required and homogeneous mixing is obtained at a molecular level. Control over composition as well as structure can be obtained, and they can produce thin films, powders as well as nano coatings. Disadvantages. It requires a long processing time, especially for the drying process, and cracking during drying occurs if it is not properly controlled, and it is also sensitive to humidity as well as temperature. Applications of the sol gel method in nanotechnology. They are involved in nanocatalyst, that is titanium dioxide nanocatalyst, on optical nano coatings which act as anti-reflective layers, then sensors for chemical and bio applications, drug delivery systems as well as ceramic and glass materials manufacturing. Comparison of sol gel method with the traditional precipitation methods. The sol gel method has low temperature compared with the traditional precipitation method, and it is having high homogeneity, and also the product form is in the form of gel films as powders, and it has better control over the size obtained, and it is observed to be more complex than the traditional precipitation method. Examples include synthesis of silica nanoparticles using the tetraethyl orthosilicate, titanium dioxide nanocoatings for self-cleaning surfaces, zinc oxide nanoparticles for sunscreens as well as antimicrobial coatings. Quiz questions on precipitation methods, sol gel technique. Explore about precipitation methods in nanotechnology. Explain the step-by-step procedure of sol gel process. Write the advantages and disadvantages of sol gel techniques. Thank you.